Good afternoon, everybody. My name is Stephen Fogle. This is my colleague Elijah Lee. We are probably the most unlikely speakers at a conference like this. My background is in psychology. Specifically, I'm a psychophysiologist. So I'm someone who measures physiological data from the human body and tries to infer psychological meaning from that. So we would like to do an interactive demonstration using a technique called galvanic skin response. So we put two tiny sensors on someone's finger, and we hope to kind of show you some live data just to give you an idea of the approach that we're taking in ARtSENSE. In order to do that, I would like a volunteer from the audience who can come and sit in the front, and it is two little wires on the finger. Would anybody be interested in getting involved? Yeah, thank you, please. So I think if you okay, so while we're doing the setup of this, I'll do a talk and an introduction. So first of all, this term biosensing and biological sensors, what it really means to me is, as I said before, it is the use of physiological data in order to infer psychological states. These can be cognitive states, such as being interested in something. Interest is something that's very pertinent, I think, to what we're trying to do on ARtSENSE. Also, we can look at things like emotional states and so on. So this is all data that we can collect. And provided that we can have someone wearing a sensor in an unobtrusive way, we can also collect this data that is continuously available. We don't have to ask anyone to do anything. We just need to wear the sensor and the data is always there. This apparatus traditionally has been associated with laboratories, and it has been associated with being very cumbersome, where people cannot move, it is uncomfortable to wear, it is very intrusive. But as time is going by, the sensors are getting smaller and smaller, and here are some examples of what we call ambulatory sensors that are Bluetooth enabled, so they're able to communicate with smartphones. And this means that we can collect data in a range of environments that were perhaps not available to us 5 or 10 years ago. I want to make something clear about what we're actually measuring and what it actually means. When you look at some of the commercial literature for these devices, people talk about things like reading the mind and reading the emotions. This is really high, I should say. What we are actually doing is we are trying to infer psychological experience from physiological patterns, and that is not very straightforward, because physiological patterns are affected by the temperature of the room, the noise in the room, whether you just had a cup of coffee, and a whole range of different things. So there is a lot of noise around which we have to extract a particular signal. But what we think we can do is that we can extract enough of a signal that is significant enough to adapt technology in real time, which is really our interest, is using these physiological data to adapt to a computer system. So what we measure is quantitative, it's about numbers. It is rather simplistic in the sense that it is not in any way a literal representation of your experience. It is not reading your mind. It cannot capture the full richness of embodied experience. It is a simple, crude measure, but still one that I think we could use. Typical ambulatory indicators of experience, things that we can use with sensors that are fairly easy to wear and can be worn inside clothing, things like heart rate, which is pretty easy to measure, which is a large electrical signal, which we measure from lots of different sites in the body. The measure we are using today, that we're looking at today, is called skin conductance level. This is basically the sweating of the skin. We take the skin of the hand, the glamorous skin, and we put a tiny electrical current through it. And the resistance of the skin is affected by the moisture level of the skin. So the more stressed or activated a person gets, and this is what we'll see later on, the more psychologically activated they get, the more the response that we see from the signal. And we can also measure breathing rate fairly comfortably. Now what we are proposing to do today is two things. First of all, just to show you how the measure works, we're going to have our participant view two segments of video footage. One is designed to be very boring, one is designed to be more exciting, just so you can see the signal changing. And then what we would like to do is to show how we apply this sort of technique to some of the ARtSENSE case studies, specifically the lens in the kitchen. So if we are nearly ready to go, normally with the signal, and this is terrible because when someone is wired up, they can hear what you're saying, and I know what I say will affect their response and so on. But Yeah. So what we can see here is a signal rising up and down, because normally we will get someone to sit and to try and get a stable signal. And another issue I think with our software is that it auto-scales. So sometimes we can lose a signal, but I think that seems to be settling down now. So if you really put the headphones on, please. Okay. So it's from the speaker, check. Okay. So, oh, sorry, before I move on to the film, this is just an example of the kind of data. This is from a paper that came out this year from a group in Germany. And what they have done is, in a gallery space, they have someone wearing a glove that had these kinds of sensors in it. And what you can see on this particular picture is a bunch of trajectories. These are people walking around a gallery space. And the green dots and the red dots is telling you what the heart rate is. So what you have when the dots are red, this means the heart rate is quite high. And what we assume on the basis of that is that these are the hot spots in the gallery, where people were excited or stimulated. So in collecting this data for the purpose of adaptive software, what we can also do is map experience and keep a record of experience in that kind of way. So I think now we're ready to do the film demo. So we just watched the film and And if we could just see the demo there, can I just show the boring film? Is it between those two spots there? So this is the more relaxing film, and that's actually a film that we use to relax people in the laboratory before we do experiments, to get them into a baseline state. And then if we jump ahead to the James Bond film, we see an increase at first, particularly with all the noise and so on, and those kind of spikes in there if you were watching it, when there was a moment of collision and stuff like that, we see a kind of reaction to that. So the reason I show you this, the reason we included this, was that when we do demonstration with the museum footage, we are obviously not seeing the same range of response. So just to demonstrate to you how the measures work. Now the next thing I would like to say is to do with of what we are trying to achieve on ARtSENSE. In a way. We are taking the approach that obviously the exhibition you've heard already is a physical space, and we also have an information space that's provided by the augmented reality. And of course, traditionally a visitor follows a trajectory in the galleries and museums through the both spaces. And normally, either with a guide or with text that are on the exhibits, these routes are static, they're bespoke, and they're designed for a general visitor. And as I think Nina said earlier, what we're trying to achieve on ARtSENSE, probably the most speculative part of the project, is whether we can use these kinds of physiological data records in order to adapt the trajectory through information space that the person experiences in order that it is things that interest them or stimulate them. So we can adapt content in real time. In order to create a loop that is adaptive, so it changes, the content changes in real time. That is variable, so people may see different things, different visitors are exposed to different sorts of stories and information, and that it is personalised for that particular person. So we'll show a demo shortly based on the Valencia kitchen, and the structure of the information space is this, is that we have an introductory piece of text about this scene here, and we basically have a number of stories. So we have 4 stories, and each of the stories has 3 levels of detail. So the idea is, we are going to show all the stories and all the levels of detail, and the idea is, can we see any changes in the physiological data that tells us that the person is more interested in one story than some of the other stories? So, and this is the way the information space looks. We have an introduction, and then we have story 1, fact 1, story 1, fact 2, and story 1, fact, and so on, each with different levels. So the narration will change according to the person's arc. But for the purpose of this demonstration, very early in the project, we just want to see if we get some kind of response. So I start the demo running now, and you should be able to hear some audio.
This is a late 18th century tiled kitchen which originates from a palace in Valencia, a Spanish city which serves as a port to the Mediterranean Sea. The kitchen depicts different scenes of daily life in an upper-class household. The principal scene, situated in front, describes the preparations of the household for a refreshment that the lady of the house will serve to her friends in the kitchen. According to the sources of the time, a refreshment was a snack or light meal served in the afternoon with drinks, sweets and chocolate. Refreshments were served at social functions in upper-class families by the household servants. To the right of the lady, you can see a male servant carrying the first dish of the depicted refreshment. For the occasion, the lady of the house is wearing a French-style dress comprising of a jacket with long tails, a bodice, and a petticoat made of a silk cloth. The dress fabric is decorated with a motif of interlaced flowers and leaves, and the cuffs and edges are trimmed with lace. The lady is also wearing a fichu or kerchief around her shoulders to complement her dress. This fashion style was very popular in Spain at the time, and can be seen today in the traditional costume of Valencia. In Valencia, at the end of the 16th century, there was a staple production of painted tile, which were used in the construction of the kitchen. By the 18th century, Valencia had become famous for the production of these tiles. From the ovens of Valencia's factories came tiles decorated in a variety of styles, including Baroque and Rococo aesthetic. The scenes depicted are painted with a trompe-l'oeil effect. Today we categorise these decorative walls as being traditionalist. To the right of the lady, a dog can be observed trying to attract her attention. Dogs were commonly kept as pets in upper-class households, unlike cats, which were used as a means of pest control.
Okay, so if I'll just review that record now. So like I said, we have 4 stories. Here is the introduction. I think we're missing a marker here, Carl, aren't we? Okay. So here is the introduction text. This is the first part of the story, which was about the refreshment. This is the second part of the story about the dress. This was about the tiles, and this was about the dog at the end. So I would say the thing you were least interested in was the dog, and the thing you were most interested in was the dress. Is that correct? Yeah, okay, good, okay. I feel, yeah, okay. So you get the idea that we can see subtle changes and try and assess the person's level of interest based on that. Now obviously there are challenges to do in terms of doing it in the real world, but the thing that we are trying to do is to provide a seamless, personalised experience by using this data in real time. And to try and use physiology to chart this trajectory and to direct the person through information space. This is an example, thank you very much. This is an example of the different stories. And you can imagine, if we had the content actually being adapted in real time, that people would go a particular route based on, the level of interest or whether low interest was projected. So, as I think we said earlier on, as Anna said earlier on, there are many, many different stories that we can tell. And the idea is to use physiology in order to tell the right story that suits businesses. Thanks.